Hello everyone, welcome to our YouTube channel, the EngiHub, where engineering made easy. We have started this YouTube channel to make the engineering subject easier to understand. Our goal is to break down the complex theories or topics into a simple steps for your better understanding and easier to learn in a quick time. Happy learning. Welcome back to the video again. Today we're going to discuss about the laws and rules of Boolean algebra in order to solve the problems with canonical forms of both POs and SOPs. When we talk about laws, right? So there are three important laws that you have to keep in mind: commutative law, associative law, and the distributive law that you have to keep in mind. Okay, so the first law is commutative law. As you can see, A into B is equal to B into A, and A plus B is equal to B plus A. So can I take an example of, let's say, for example, A can be 2 and B could be 3. So 2 3s are 6, and 3 into 2 is also 6. What does this law say? Irrespective of the position of a number, okay, the answer you will get is just the same. Okay, so what I mean is, even 2 into 3 is also 6, and 3 into 2 is also 6, and it's the same for addition as well. You can also try it when you apply A is equal to 2 and B is equal to 3, and you'll get the same answer, 5 and 5 here. So associative law. So in associative law, it also has formulas for both addition and multiplication that you have to keep in mind. Okay, so when we talk about the multiplication formula here, it is A into B into C. This B into C is in bracket. So as you know, the BODMAS rule. Okay, so you should be knowing the BODMAS, right? So for the first one is BODMAS. So BODMAS says brackets are the first order or preference that you have to give, right? So whenever you see brackets, so that is the first preference that you're going to do. For example, let's say I'll take A to be 2 and B to be 2 and C to be 3. Okay, now what I have to do is, first I have to multiply the numbers which are there inside the bracket. So 2 3s are as what? 6, and 2 6 as 12. So I got 12. You can do the same thing on the other side as well. You will be getting the same answer. So as you know, the A is 2 and B is also 2 and C is 3. So first, 2 2s are 4 because we are following the BODMAS rule. So bracket, whatever the numbers which are there inside the bracket, that we have to give a first preference. So 2 2s are as 4 and 4 3s are as 12 again. So did we get the same thing on the both sides? So this is what associative law says. So it's just the same for even both multiplication and addition. You can take the values of A, B, C according to your assumptions, and you can try it. So talking about the last law, the distributive law. Distributive law is having only one rule or law that in general, because it consists both multiplication and addition operation in single formula. So A into B plus C in a bracket. Okay, let's say A can be 3, B is 1, and C is 2. So as you know, we are following the BODMAS rule. Whatever there inside the bracket should be given the first preference. So 3 into 3 is 9, right? And the same thing, if I substitute the value of A is 3 and B to be 1, plus 3 into 2, 3 1s are 3, plus 3 2s are 6. 3 plus 6 is 9. Didn't we get the same thing on both sides? This was all about your laws, and we'll continue with the rules. Now we'll learn about the rules of Boolean algebra, which are also very important in order to solve the canonical forms of both POs and SOPs. When we talk about the rules of Boolean algebra, there are actually 12 important rules that you have to know. So the first rule says that A plus 0 or A logical or 0 is equal to A. What does this mean? So here the plus can be your normal additions, or it can be also a logical OR gate. Okay, so when I'm substituting the value of A, I must follow the binary code or binary values. Okay, binary values is either 0 or 1. Okay, so in case of 0, what would be my answer? When I substitute A is equal to 0, right? So what will be the answer? So A is 0 plus 0 is 0. So you can see when I gave the input of 0, so I also got the output as 0. So this means, so whatever the input that has been given, the same output I have been getting. So A plus 0 is equal to always A. So I can also test with another input. When A is equal to 1, let's check it out. 1 plus 0 is actually 1. So you can see whatever the input that you are providing, it's directly connected to your output. So that's the reason we say A plus 0 is equal to A itself. When we talk about the second rule, A plus 1 is equal to 1. The same case, we have to follow 0, A is equal to 0 or A is equal to 1. Okay, so when I take A is equal to 0, 0 plus 1 is equal to 1, you can say, and A is 1, 1 plus 1 is also 1. So from your logical or truth table, you can go and check 1 plus 1 is also 1. Okay, so coming back to the third rule, so here it says A into 0 is equal to 0. Obviously, you know, by simple mathematic operation, anything into 0 is 0 itself, right? We don't have to even prove it. Let me just say A is equal to 0. 0 to 0 is 0. A is 1, so 1 into 0 is also 0. You can see that is the same, still the same. Whatever the number you substitute in the place of A, you will be getting still the 0 as an answer, because anything into 0 is 0 again. So A into 1 is A. So when I substitute A is 0 here, okay, now I'll get 0 into 1 is 0. Am I getting the same, whatever the input that I provided as an output? Yes. We'll check it for A is 1. Okay, when A is 1, 1 into 1 is 1, right? So am I getting the same input which I provided? Yeah, I'm getting the same output which I provided as an input. So when we talk about the fifth rule here, A plus A is equal to A. So what does this mean? So A plus A is equal to A in the sense, for example, if I take A to be 0, right? So 0 plus 0 is equal to 0 again. So you can see whatever the value of A that has been provided as an input, the same number is been getting it as an output. So A is 1. So 1 plus 1 is 1. From logical or a hot truth table, it's 1. So you can say that A plus A is still A, right? So that was your fifth rule. When we talk about the last rule, A plus A bar is equal to 1. Okay, it might be confusing for you here, but it is A plus A bar is equal to 1. Okay, so A bar, right? A bar is nothing but the complement. If in case, let's say you had 0 bar, which means 1. 1 bar is 0, the opposite of it, complements. Okay, now if I take A to be 0 here, if I take A to be 0, okay, so here in place of A, I can write 0, and A bar is what? 1 is equal to 1. Am I getting the same thing? So 0 plus 1 is 1, which is true, and we'll take A to be 1 here. When I take A to be 1, here in place of A, I can write 1, and A bar, if A is 1, so 1 bar is actually 0. So 1 plus 0 is actually 1. So this is your sixth rule. Okay, so when we talk about the seventh rule, A into A is equal to A again. Okay, what does that mean? Let's say we'll take A to be 0 first. Okay, I'll substitute the value of 0 here in place of A. So it would be 0 into 0, which is actually a 0. Still the same, actually, this rule you can see A plus A is equal to A. The same way, it is A into A is equal to A. Whatever the input that you are providing, the same output you will be getting. We'll check it for A is equal to 1. So 1 into 1 is 1. So you can see whatever the A value that I have provided as an input, I'm getting it as an output. So I still can say A into A is equal to A itself. Talking about the eighth rule here, A into A bar is equal to 0. How does it work? So let's say A is equal to 0 now. In place of A, I'm going to substitute the value of A to be 0. And A bar, you know, when I have a 0 bar, so it will be 1. So am I getting 0 into 1 is 0? Yes. When A is equal to 1, okay, so I'll substitute the value of 1 here in the place of A. So 1 into, I'm substituting the value of 1 here. 1 complementary is what? 0. So 1 into 0 is 0. So I can say that A into A bar is actually 0. So that's a rule. Okay. The ninth rule is very simple. Okay. Whenever you see double complementary, you can just cancel it directly and say it is just an A bar. We can prove this as well. So you know, this is double complement that we call. Okay, this was all the single complement that you had studied. Now we'll see how you can perform a double complementary things. Okay, so let's say A can be 0 now. First I'll take A to be 0. Okay, in the place of A, if I substitute the value of 0, it is double complementary. What should I be getting? So you know, 0 complementary is 1. That is 1. So there is 2 complementary, right? So first you have to take first 1 complementary you have to do. So let's say 0 complementary is 1. Okay, and there is again another complementary that you have to know. There is again another complementary that is on the 1. So 1 complementary is what? 0 again. Am I getting the same thing? Or in general, you can just directly cancel it. Okay, so whenever you see double complementary, you can directly cancel it and get the same answer on the other side. If you want to prove it, let's say, as I told you, 0 complement is what? So first complement we're going to take. So 0 complement is 1. And what about the second complement that is there? So 1 complement is again 0. So this is how we proved it is 0. Okay, you can also check it with 1 by taking a is equal to 1 in place of a. Okay, let's study about the 10th rule here. It says a plus a into b is equal to a. So we're going to take a case here. We'll take a to be 1 and b to be 0. Okay, or vice versa. You can take anything. So when a is equal to 0 and b is equal to 1, okay, how does this formula work, or how does this rule work? So when I substitute the value of a here, it is 0 plus, here in place of a it is 0 into, what is the value of b? It is 1. Okay, so 0, I can write it again, 0 plus 0 into 1 is 0 actually. So 0 plus 0 is actually 0. So you can say given a plus ab is equal to a, whatever the value of a that you have given as an input, you'll be getting as an output here. You can see I had given the value of a to be 0 and value of b to be 1. So I'm getting a is equal to 0 as an input and I'm getting 0 as an output, which satisfies the rule of 10th. Okay, so talking about the 11th rule, a plus a bar b is equal to a plus b. So the same case you can take, let's say a is equal to 1 and b is equal to 0. I'll just change the numbers now. So in place of a I can substitute 1, and in place of 1 bar, actually 1 bar is nothing but 0 into b is 0. So you can say this whole thing is actually 1 plus 0. How? 1 plus 0 into 0 0. So you can simply say this a plus a bar b is equal to actually a plus b in simple words. Okay, you can take other examples too, like b is equal to 1 and a is equal to 0. You can also do it and solve it. Talking about the 12th rule is a bit like distributive law. Okay, so here when I take a to be, let's say a to be 1, b to be 0 and c to be 1 again. Okay, when I substitute it back into the rule here, so I'll get 1 plus 0 and 1 plus 1. Okay, this is the BODMAS rule. So first you have to give a preference for the numbers which is there inside the brackets. So 1 plus 0 is 1. Okay, and 1 plus 1 is actually 1. So it is okay. So how things work here, in the sense you know that here 1 plus 0 and 1 plus 1 is equal to 1 into 1, right? So whatever the value that you had given, let's say it was 1 here on the left hand side, right? And when we talk about the other side, even if you take a to be 1 here and b to be 0 into c to be 1, you still get the same thing on the right hand side too. So 1 plus 0 into 1 is 0, which is actually 1. So left hand side is equal to RHS. So hope you liked the video and understood the concept. If you did, please like and subscribe the channel.